All right, we'll get started. Good morning, everyone. We will just continue with what we discussed yesterday, and then we'll see a few more basic topics, and then we'll wind off this demo session, and then we'll actually start our regular classes from next weekend onwards, the coming weekend onwards. That's going to be on 29th and 30th. So I'm just going to show you all the schedule and how the course content. What we discussed yesterday was we started with the understanding of what's the need of RAC and why Oracle DBA has to learn this RAC course because of the many reasons. Once you are a RAC expert, you'll get a lot of opportunities in the market, and most of the customers or most of the clients, they are going with the RAC as one of the preliminary requirement for their database setup. Nowadays, like you can rarely see the standalone databases. Even though if you see the standalone databases, and then ASM storage is mandatory for them. So there, most of them, they will go with the ASM as a backend storage. Right. So there are many other reasons. RAC has its own advantages and future, like scaling up, scaling down, and high availability, and so many other features. That's when RAC becomes so popular, and then very mandatory required skill for all the DBA. So learning RAC is uh, you know uh, having a lot of advantages. Along with that, it's going to help us for longer career build. And then we started with the course content. We discussed about what are the course content, how it looks, and then uh, what is the course content, how, and what based on what this course content is built. So everything we just discussed, and then after that we gone through some of the checks for my course, mandatory checks. So you had to learn database as one of the basics stuffs. So you had to you should know your database architecture, and you should know your basics of your RMAN and backups and recoveries, and you should know basic storage concept and ASM, and other DBA day-to-day activities. Once you know all of them, then the RAC course will be the much easier one. If you don't know, no worries, but you have to struggle a lot along with this course. While learning this RAC course, you have to spend some more extra couple of hours and then try to understand the database concept along with this RAC concept. Right. So this, if you know the prerequisites, then that's well and good. Otherwise, like you have to spend some extra hours and then try to learn parallelly both your database and RAC. Though that's one of the preliminary checks you have to make sure that abide by that. And then some of the other things for this course is uh, this course is going to be, if you talk about the schedule, this course yesterday and today are going to be 2 demo classes, and then actually it starts with 29th onwards, 29th and 30th. So that's next to coming weekend. So every day it's going to be like 8 a.m. to 12 a.m. That's 4 hours on Saturday and 4 hours on Sunday. It's going to be approximately like 40 to 40 hours is the entire course duration. And then these are the like 5 to 6 weekends what I scheduled it. And then once you do a registration, you will get all these PPTs, whatever I showed you, all the master PPTs, and then individual course, individual chapter wise PPTs. All those PPTs, you're going to get it over there. So if you go here in Google Drive, you're going to get the PPTs by chapter wise, and you're going to get the PPT of this entire this is a master PPT what we're going to refer, this one. So this is a single PPT clubbed together, or if you want like each chapter wise, you can refer those individual PPTs. And then there's a daily classes folder. Whatever the session we're going to record, every day the session will be uploaded here. So as I discussed yesterday, before you start with the RAC class, you have to go through some of the prerequisites videos. So these are the prerequisites videos, like day 1, 2, 3, 4. So these are my database prerequisites videos. So I just uploaded here. So who are registered for this RAC course, they have to go through this particular 5 to 6 videos. And then these are like yesterday's demo 1 and demo 2 session, whatever we took 2 sessions in the middle. So those 2 sessions I uploaded here. And then today's session, I'm going to upload it here. So these are the prerequisite sessions you have to go through and then watch it before we start our actual class. And then if there are any command, I'm going to run it on the command line. All those command will be captured, all the run log will be captured and then uploaded here in this daily session log. and so that you can refer both the videos and then the run logs together, and then you can run and you can execute in your own lab. And then the course materials all uploaded here, some of the workbooks, some of the step-by-step guide to build your rack and other stuffs. 11G rack, 12C rack, and 19C rack, all of them are like uploaded. You can try whichever various versions. And then some of the lab exercise are all uploaded here. And then your ready VMs and all uploaded here, so you can try and practice out over there. So that's all. Once you've done with your course registration, you'll get all the PPT, workbook, lab materials, all the softwares, patches, ready VMs, and then the previous batch recordings and daily logs, daily recorded videos, all those things. You will get it out. And then the course fees is going to be 15K. So as everyone already aware of that. So you have to make a payment by bank transfer or by Google Pay or Phone Pay. Once the payment is done, you just send me the screenshot along with your email ID. I'm going to grant access on our Google Drive, and then we'll get started from there. Right. So I'll just brief it. Any questions in the middle? You can feel free to raise your hand, or you can post your questions here in this chat box.
Malik,
yeah.
I don't have a question, but I have a concern.
Yeah.
I'm not fluent in this course, so I'm a learner. So sometimes if I have a difficulty, I send my question and then I cannot get the response quickly. And that discouraged me to keep going in my learning.
Okay.
So I need your availability. If I send something, please can you answer to me?
Right. So that depends what time you're gonna send it, right? So you are based in US. I'm based in India. So try to send it out India timing after our daily classes, probably around 10 a.m. onwards, or 10 or 11 a.m. So probably I'll respond it back. Otherwise, it's going to be next day. Because because of the time.
Yeah, but the problem sometimes I'm in front of my machine and then working. I run some command.
Best way is to post your queries on the group. We have a dedicated WhatsApp group. If I don't, I am not available. If I don't respond, there might be other colleagues, your colleagues, the group of people. If they know that, they will definitely answer to that query. So rather than pinging one-to-one, post it in our group. So that will be the best way or quickest way to get the resolution.
Okay, I'm gonna try this one to see.
Right.
Thank you.
Right. So we started with understanding the environment setup. That's a purely part of the database course. So, but still, it's mandatory to know as part of this RAC course. So I just uploaded these slides here, and then as I told, these are the videos. So you have to go through those. Those are the prerequisites videos. So you have to go through that. So those prerequisite videos, like how to build your VM, how to set up your file system, and how to understand your partitions, and how to add a disk, how to format a disk, how to mount that disk, and how to set up your M repository, how to play around your RPMs, and other tools like WinSCP, PuTTY, Mobile Extreme, and Remote Desktop. So all those tools and all those videos are explained over here. So you can just go through them and then be familiar with that. And then similarly, some of the networking concept, all of the preliminary or prerequisite networking concept. So I just covered here what is DNS, DHCP, name server, forward resolution, reverse resolution. So you are gonna learn all of them in depth in this RAC course. But before that, if you go ahead and refer these videos, those will be very, very helpful. If you see here Linux networking, basic understanding, and networking Linux administration. So this is the one which will talk about your networking and other things. The prerequisite checks, the prerequisite session for environment setup and Linux basics. So that's whatever we talked about, our partitions, RPMs, and other things. So you just go through these videos, and then that will help you for understanding this RAC course is much easier. But and then we started with introduction to our clusterware and some of the RAC architecture. We started with the difference between our standalone and RAC databases. So standalone is like one-to-one mapping. RAC is like one-to-many mapping. There'll be one database at the backend. There'll be many instances will be pointed to one single database. That's a RAC one-to-many, and then single instance is like one-to-one mapping. And then some of the RAC features I just mentioned here. RAC is configured with multiple instances running on different servers or different nodes. We can call it as a nodes. Those are like different servers. And then multiple instance share the single physical database. That's the storage is a common single physical database. And multiple instance resides at different nodes and communicate each other via cluster interconnects. So all of these are like RAC features. How altogether you will make your RAC clusterware. So that's what we understood here. Your node 1, node 2, node 3, node 4, node 5. Like will be having a multiple cluster nodes, and then we'll be having its own clusterware software. That's your grid infrastructure software. And the grid infrastructure software internally has your clusterware software and then your ASM storage. So ASM stands for your uh, uh, ASM automatic storage management. That's a kind of a storage feature which is provided by your Oracle. If you don't use your clusterware and ASM and your ASM storage management, so you can have something called a shared storage between your cluster node, and you can still form your clusterware. So that's other way of building up your clusterware. But Oracle strongly recommend to use your ASM storage and ASM as a clusterware software, so that it has its own advantages, mirroring, striping, and uh, you know uh, some other like maintaining your database files and control files and data files, and the communication between your database and ASM. So ASM has its own advantages and future. Better to use your ASM storage for your databases rather than some other third party common storage. So better to have your ASM as a storage for your databases. So that's like your common storage where you're going to store your OCR, your voting disk, and your database files, your control files, your redo log files, your archive redo log files, and your flashback logs. All those things you're going to keep it as a common storage, and all the cluster node are going to able to access those common storage. And any application or any end user connect to any cluster nodes, they will able to access the same data. So this is the high level architecture we discussed. So any one of the cluster node will access the same storage, so that if in case any one single node fails, so other cluster node are available to serve end users or the business application connections. And then we started with the understanding of the scan in brief. The scan is again one of the very brilliant feature in our clusterware, where which will manages your load balancing. For example, scan will be having default will be having a three scan listeners. So that's not a limitation. You can have a 4, 5, 6, whatever want you can have it, but 3 is the default one. And Oracle also recommends 3 is more than enough. But some customer might be using 4, 5, 6 based upon their needs, but 3 is more than enough. And then those 3 scan listeners are smart enough to handle your load balancing at your cluster. And you might be having a 4 node cluster, 5 node cluster, 6 node cluster, and your scan listener will take application or client connection or incoming connection, and then it'll pass that connection to any one of your cluster node which is least loaded. Your scan will understand which node is heavily loaded, which node is doing a lot of work, and which is doing less work, and it will pass the connection to that least loaded, or which is doing very less work. It will pass the connection to that particular node, and user will be connected to that particular cluster node, and then his SQLs or operation is continue to work. So we'll understand how it works in details, but it's a high level how the scan works.
Malik,
Yeah.
sorry, I have a small doubt here.
Yeah.
So like you are mentioning 3 scan listeners are default, which is recommended by Oracle.
Right.
And if we like I see like there are 4 node rack here.
Right.
Even if we are having 1 node rack, like do we get a default scan 3 scan
Right.
listener?
You can have there is no single node rack. At least you need a 2 node in order to form a rack cluster. With a single node, you cannot do a cluster. Minimum is 2 node. Even though if you have 2 node, 3 node, 4 node, 5 node, 3 is the default one. So that's a default configuration. You cannot go lesser than 3, but you can go more than 3.
Okay, but like there is a concept in Oracle like rack 1, right? Like maybe we can add instances later, but we can have 1 node in the rack setup.
One node is not a rack. If you install
Rack,
one node, RAC
But
one node is that's a separate database. You forget about the database right now. I'm talking about only grid infrastructure, your clusterware. In order to form a cluster first, at least you need two nodes. Without two node, you cannot do a single node RAC clusterware setup. In order to form a clusterware setup, you should have at least two nodes. So we're going to see it during the installation. If you just select only one node and then try to select a real application cluster installation, it will not allow you. At least you have to select two nodes, then only you are able to install a real application cluster.
okay, yeah. Thanks.
Right. So we understand some more deeper concept about a physical IP will be tagged to each individual cluster nodes, and each of those cluster node will be having its own node VIP, and then each of these cluster node will communicate with the interconnects. That's a private network, and then your scan will be again running under VIPs, and that will be your public IP, public network, and all the end users or the end clients or the application will connect using the scan. That scan is again a VIP, and then via scan, that connection will go to that particular node on node VIP, and then it will connect to that particular database. And if that node goes down, that physical IP will go down, and your VIP will be floating in your cluster, and then that will be picked up by any one of your existing running cluster node, and your application connection will go to that particular node, and application connection will continue to work. So you no need to reconnect again. For example,
A
this is a
quick
mobile.
question. Quick question here.
Yeah.
Okay, so let's say if node 101 goes down, we have
Yeah.
4 nodes as per
Yeah.
the pictures. You
Yeah.
are saying so whatever coming in 105 automatically routes to some other node, right? So does that mean the other 3 nodes will handle 4 VIPs?
Right.
Okay.
Right. You're gonna see it like we'll shut down one of the node. For example, if I go here, .inv plus ASM1. So I'll just connect to one of my node, 2 node cluster it is. So CRSCTL stat resource -t. So if I go here, I have a node 1 VIP, I have a node 2 VIP. This node 1 VIP right now running under node 1, and node 2 VIP right now running under node 2. The moment I shut down node 1, this particular node 1 VIP will go to my node 2. So your node 1 VIP will be up and running, but which will be running under node 2. You will see the node 2 here instead of node 1.
Okay.
You will see node
Got
2.
it.
So it means whatever the
Okay.
connection comes to node 1 VIP, it will go to node 2.
Okay.
Right. So we'll see more how it will work, that load balancing happens when node goes down and all those things. But this is the high level architecture how it goes. But remember, your node VIPs and your scan also runs under VIPs. Your node also runs under VIPs, and your application whatever connects, it will connect to your scan VIP via node VIP, and finally it will connect to your database. And your VIPs and your node IPs and all are like your public IPs, publicly accessible. But whereas your interconnects are private within that cluster, so that cannot be accessed using publicly your PuTTY or whatever it is. That's a private to cluster nodes. And then your node heartbeats or your disk heartbeat going to happen via your private network, whatever that interconnects. Right. So that's a high level understanding of your scan and then the RAC concept, how internally communication happens. And then we talked about database is kind of a shared storage here, and all your cluster node is going to access your shared storage. And then what are the files you're going to keep it inside your shared storage? So you will be having your OCR voting disk, and you'll be having your database files like data files, control files, reader log files, your SP files, password files, and your RAC log files. Everything you are going to keep it under your shared storage. And then this clusterware files cannot be on your ASM prior to your 11G release 2. 11G release 2, your clusterware files will be in somewhere in our shared storage. And in 11G release 2 onwards, your clusterware files are started storing inside your ASM. That is your OCR and voting disk or your clusterware files. And then the communication used to happen with the fiber channels. So we need like high speed network between the communication between your cluster nodes. So we basically prefer to have a high speed network. Like most preferably we'll go with the 10 gig. Earlier they used to have like 2 gig, 4 gig channels and all, but nowadays like they're going with the 10 gig, 20 gig channel between cluster node communication. And then shared storage, you can go with whatever the third party storage vendor. You can go with any SAN, NAS, NetApp or whatever. You can use any kind of storage for uh, farming your shared storage. And then finally you can use your ASM integrated file system that will form your shared storage ASM disk, and then out of that you're going to create your disk groups. And then supported files in your ASM, all your data files, control files, SP files, your password files, redo log files, archive redo log files, your flashback logs, your data pump sets, and your blockchain tracking, you can keep it inside ASM, and your RMAN image copies, backup set, you can keep it. Your OCR and voting disk, you can keep it inside your shared storage. So all of them, you can keep it inside your ASM. And then again, some of the mandatory background process, what we talked about, some of your GCS, global cache service, very mandatory and important service, which will help for your cache fusion. One of the common interview question they will ask, what is cache fusion? Cache fusion is nothing but if any block is held by any of your cluster instance, if any other instance is requesting for the same block, so the block will be directly transferred from SGA to SGA, one node SGA to other node SGA. If I go back here, and if I take this 4 node cluster and I have a modified block here, the SGA of this node 1 has a block here, and somebody connected to node 4, he needs the same block. He don't need to go to storage and get the block. He can directly request to node 1, and then node 1 will directly send a block from that SGA to node 1 to node 4. And then this particular user connected to node 4, he can get that modified block. So this is called your cache fusion. So one of the commonly asked intro question, what is cache fusion? Right, and then again, this will be managed by your GRD, that global resource directory, and all those things concept will come. So global resource directory will be having the information about which node is having which modified block. For example, I said like randomly I said node 1 is connected, he needs the block, and then the modified block is available on node 1. How this node 1 knows that a modified block is available in node 1? It might be in node 2, or it might be in node 3, or it might be anywhere. But how this node 1 is aware of that where is modified block? For that, there's something called a GRD, that global resource directory. We like that's a table which will be having information about which node is having which modified blocks, and whichever user comes and request, and your GRD table is responsible for picking up that and rerouting that connection to that particular node and getting that particular information. So all those things we'll talk about that. And again, some of the other background processes like NQ processes, because if it's a multiple in RAC nodes and all the user connected to different RAC nodes, they cannot modify the same blocks over and over again and again. So that's going to be a majority of our integrity concerns. So in order to avoid that, we have something called LMS, LMD, GS, Global NQ Service, and LMON, and then LCK. These are like locking mechanism, so that one user is modifying a single block, so other user can wait, and then once that user release the lock, other user can modify the same block. So all those concepts we'll understand with all this locking mechanism. And then some of the other files, your control files, which records, these are like typical architecture understanding. What is the control file, and then what's the use of that? What's your redo log file? What's the use of that? What's your database files? What is your server parameter file? What is your password file? All of them are like basic understanding of database, but I just given some brief description about all of them. Just go through them. And then I talked about our cluster component, like your OCR and voting disk are started keeping inside your ASM, starting with your 12C release 1, sorry, 11G release 2. And then the voting disk based upon the disk high availability. If it's the external redundancy or normal redundancy or high redundancy, external redundancy means no mirroring. Normal redundancy is a two copies, and high redundancy is a 3 copies. So based upon your disk mirroring, so if I connect to my ASM CMD. ASM CMD is again command line tool that you can manage your disk groups. So to go inside your ASM command line, you can type ASM CMD. It will go inside your ASM command line. You can see ASM CMD command line LSDG, which will tell you whatever the disk group you created are in what mirroring. So all are like types of mirroring. It says external. External means no mirroring. Instead of that, you might see normal. You might see high. If you see normal, it's kind of two copies of each whatever the block or whatever the data you are going to write it inside this particular disk groups. And if you see sometimes high redundancy means three copies. Whatever you write a single letter, it's going to be two copies are written into that same disk group with the in the different disks. So all we can talk more on that, but based upon the voting disk. So whatever the voting disk, you're going to create it on whichever the disk group. So based upon the mirroring of your voting disk, you're going to see how many copies of your voting disk. Right now it is a external redundancy. So if I do CRCT query vote disk, and I'm just going to run a CRCTL query CSS vote disk, I'm gonna see only one vote disk, which is under my data disk one, dev Oracle ASM disk. So which is having only one disk, and one voting disk is resides under one disk. So in case of this particular disk is corrupted, my entire cluster is gone. So I don't have any backup of my voting disk, right? So you should have a valid backup of your voting disk regularly. When the moment you take your OCR backup, automatically it will take your voting disk backup. So in case of this particular disk corrupted, you can rebuild your voting disk with the help of your OCR backup. So that's why it is recommended to have your voting disk in a normal redundancy or high redundancy, so that you'll be having a multiple copies of your voting disk, so that you can rebuild your voting disk online from one disk to other disk if you have like multiple voting disks. So right now it is having only one voting disk, which is because of it is having external redundancy. This is like voting disk. What is voting disk? Why we need it? Like all your cluster nodes will go and communicate with the voting disk. They will register themselves. Okay, so and so time I'm alive, I'm part of this cluster. So each of every cluster nodes will regularly go and register with voting disk regular interval, so that they'll just register themselves that we are alive, we are part of this cluster at this time. Regularly they all will go and register. Whichever the node is not able to communicate or not able to register with my voting disk, that node will be evicted from the cluster. Your CSS will go and then evict that node from your cluster. And then your cluster registry, again that cluster registry is having all the cluster where whatever the resources part of my cluster where all those resource information will be available inside your cluster registry. For example, your VIPs or your scan or your services, most of them are part of your clusterware services. All will be like registered inside my clusterware registry software, clusterware registry configuration file. And then each of node will be having its own local registry that will be like local to that particular node. Whatever the resource, only part of that particular node will be registered inside that particular node. So your OCR and OLR is the local to that, and then OCR is at your cluster level. And then both of them will be available inside etc Oracle OCR.loc, and then your OLR will be like etc Oracle OLR.loc. So you're gonna go ahead and then cat each of them on each of those nodes. You can see it is my OLR, your OLR config. This is your OLR config, user and app Oracle CRS data, node name and OLR, and then node specific that OLR and your CRS home. Similarly, you can cat it for your OCR, and OCR is again, it is going to be inside your disk group. You can see OCR config location plus data and node cluster, OCR file, and this is a registry. This is inside your cluster where, and OLR is inside your local node. And if I go and check same thing on the other node, you're going to see the same thing. OLR is local to that, and then OCR is common to your cluster. OCR.loc, you can see it is inside your cluster. It is a local only is false, so it's not a local, it's a cluster wide. And then
Malik, sorry, one question here.
Yeah.
Like in a RAC database, how you know that whether it's a RAC or it's a non-RAC or it's a
Okay, so one simple question: the moment I logged into this node, assuming that I logged into this node 1, the moment you do ps-ef grep smod, and then if you see there's something called ASM and suffix with 1, 2, 3, 4, then it's a RAC. If you don't see that suffix 1, 2, 3, then it's a standalone. That's the one thing you need to understand. And then whether
generally
it's
this is a interview question also. That's the reason I ask generally what they are looking for and what
right.
is
So
the
this is one thing, like whether it's a RAC or not. If you see something called ASM 1, 2, 3, then it's a RAC definitely. And then other way to check whether it's a RAC node or not, like OLS nodes. Just type OLS nodes, and then you'll see whether it's a RAC node or the RAC 1 node or it's a single node standalone. It all will get like OLS nodes. Whatever the part of your cluster nodes, all node will be displayed here. The moment you just type single OLS node, you'll get to know here. And then other way to check it here, you can cat your etc Vara tab, and then you will see your ASM setting over here, and then set the environment to your ASM env pipeline grep Vara, and then it will be set to your ASM, and then do crstl stat resource -t. And then if your crstl command is working, then it's a clusterware. If it's other than your clusterware, your crstl command will not work. So there are many ways you can answer for that question. Yeah, these are a few of them. And then again, OCR will comes into picture when you are having a clusterware. If you're standalone, you don't see that OCR. Other way, like you can see this your OCR file. Your OCR file will comes only if it's a RAC. If not, it not come. Right. So that's about your OCR and OLR.
One question.
All right. Yeah, please.
Regarding the voting disk, which you have told, like it will capture the health of the nodes.
Right.
So, is there any way like we can? Is there any log which will be human readable where we can see the voting disk?
There's a KFORD utility. KFORD is the one which will give you the content of your voting disk. You can use a KFORD. Just do KFORD is a one utility, and there's a KFED is other utility. These are like KFORD and KFED are the one which will read your voting disk. So we'll talk more on that, but yeah, these are the two utilities. You can make use of them and read the voting disk. So this is your voting disk. Where is that one? So this is your voting disk. You want to read this particular disk. So you can use the KFORD and then vote disk and then pass this disk information. It will give you the content of that vote disk. But again, doesn't make sense reading your voting disk because only your clusterware can understand that. But again, these are the two utilities. You can make use of them and read your voting disk. And even OCR also you can read them using KFORD.
Malik, you are also covering this voting disk backup and restoration.
Yeah. So it will be like part of this course. That's a mandatory as a part of your clusterware administration course. You should aware that how to take your OCR backup, OLR backup, how to restore your OCR and OLR. In case of your OLR corrupted, OCR corrupted, how you're going to restore with the backup. All of them will be covered. Right. So that's
Malik,
yeah.
as you, does this OCR and voting this continuously gets changed so that we need to take the backup regularly, or we can take the backup once and keep it?
It is like by default, whenever there is a change happens inside your clusterware is smart enough to take automatic backup. And then clusterware is already set every 4 hours, it will regularly take a auto backup. So there's auto backup is already kept. And if you go inside your, for example, if I go here, this is my voting disk and OLR. Your voting disk and your OLR and voting disk, everything will be regularly backed up by clusterware itself. You no need to worry at all. But if at all you want to take a backup, you can take a backup regularly once in a day or once in a week or once in a month. You should take a backup by your own, but you no need to set up.
Backup is at some other location.
It will be of the same location. So I'll talk about that. Where is your automatic? That's one of the common question in the interview ask. What is my voting disk and OLR and OCR backup location, where it's going to take a backup, and then how frequently my OCR backed up by my clusterware, and then what are the utility to take a backup of my clusterware, OCR and voting disk and OLR file. My OCR backup is happening. Do I need to take a voting disk backup? No, you don't need to take a voting disk backup separately, because once the OCR backup happened, that OCR is going to take your voting disk backup as well. So all of these are like some of the common tricky questions. We'll all discuss much more, but yeah, it is advisable to take a backup regularly, once in a day or once in a week. But if you don't take also, don't worry, your clusterware will take a backup every regularly every 4 hours. And then in case of if you the moment you do any changes in your clusterware is smart enough to take immediately that OCR and voting disk backup. Right. So
Okay.
those are like built-in features.
Malik,
Okay.
one question.
And Malik, we have SQL developer for running SQL commands, है ना? So do we have any other utility to run the ASM commands?
ASM command, whatever the ASM command, how you are connecting to SQL developer to your database. Similarly, you can connect to your ASM using your SQL developer with whatever the username and password you're going to pass it. So same way you can go ahead and pass it, and whatever the command you're going to run it. But what's the point of connecting with the SQL developer? Because we are not going to do much with the SQL developer inside ASM, other than managing your disk groups and other things. Only the database is the
like
one where
output is more readable in SQL developer, na? Like
right,
sometimes we need to format the like
right. You
SQL.
can connect your ASM in SQL developer.
Okay, so we need to just give the username and password over there.
Right. Sys username and sys password. How you connect to your database? Same way you can connect, but gonna connect to your SQL developer.
Okay, thank you.
Malik, one question: is the voting disk only store Oracle related binary information or user related
Voting
information?
disk will not store anything. Voting
Okay.
disk will store only that node information. Voting disk means it's just a disk. All your cluster nodes will go and register. Okay, this time, this second, this minute, this millisecond, node name, I'm available, I'm part of this cluster. It's going to register that information inside your voting disk. Apart from that, you don't see anything inside your voting disk. Your OCR is the one which will be having all your cluster related information. Whatever the resources part of your clusterware, all will be available inside your OCR. OCR like your Oracle cluster, that's a cluster level related information services, all will be available inside your OCR. And your OLR, that's a local to that. Local to that means the moment you run this CRSCTL stat resource, you'll see some first keyword is local resource. Local resource means these are your local resource, like your listener to that database, your CHAD helper, net1 and ONS. These are your local resources, will be part of your OLR. And then cluster resources, these are your cluster resources. You can see whatever you're seeing, these are your cluster resources, will be part of your OCR. And only not this much information, there will be much more information inside those files. But just to give the difference, whatever the resources at your cluster level will be a part of your OCR. Whatever the resources only to that particular node will be part of your OLR.
All the listeners need to start by ourselves, or it automatically
If you
started?
register here, for example, this particular listener is registered in cluster, so automatically your clusterware will take care of starting and stopping your listener. And if you don't register this one, you have to manually start and stop the listener for that database.
In listener.vara, we need to register, right?
You have to use something called SRVCTL register listener name, Oracle home, and then other information you have to pass it. You have to use that SRVCTL command to register that listener with this particular cluster. If you don't register it, it will not come here. The moment you do CRSCTL stat resource, you don't see that listener information here. If you register, then only it will come. Otherwise, you don't.
In standalone, we are using a listener.vara file, right, to register the listener information. Oracle
that you have to build your listener inside your listener.vara file. All the basic things you have to do it. Once
Okay.
you do all your listener configuration in listener.ora, and then after that only you have to register with the clusterware. If you
Okay.
don't register here, you have to manually start and stop it from your listener.ora. If you register here, you no need to stop manually. Everything will be handled by your clusterware.
Okay.
But the backend story is remain same. Configuring your listener in listener.ora, TNS files, all will be like same as it is. You have to do it. Those all step by step.
Okay.
Right. So this all just basics of your clusterware, how it works. And now we'll see how my clusterware startup sequence works. And I talked about here CRSCTL stat resource -t, which will give me all the cluster related information. But I don't want all the cluster related information. I want only the cluster resources, cluster services. With the same command CRSCTL stat resource -t, this will give you everything about my cluster. So with this -t, if you pass -init, init is like init resources, whatever the daemons for my clusterware services. If you just pass -init, which will give you only that clusterware resources, clusterware daemon, clusterware services, which are mandatory to run this particular clusterware on this particular node. You have to pass this -init. Whenever you're gonna shut down and start up your, whenever you're gonna bounce your clusterware, you have to regularly keep checking this init, and you'll see what all processes are starting, what all processes are shutting down, all those things. You'll see what is coming up, coming online. And then you might be having question, what is this target, what is this state, what is this server, and what is the state details. So all will see more details, but just a quick brief. In order to check what are your cluster services or demands, you have to use the CRSCTL stat resource -t -init. -t is like, it's gonna give you tabular column. If you remove this -t, you don't see that tabular column here. If I just say -res, sorry, you're gonna get like list format. So if you like resource -t, that will like your tabular column, you'll see it over here. And then this particular resource, whatever you're seeing here, some of them you will see, like if I go back here, some of the resource you're seeing like vara dot. What is that vara dot? And some of the services, some of them will be ending with .vip. What is .vip? Some of ending with .db. .db means what? Some of are ending with what is that one? .asm network. Some of them are .asm group, and some of them are like .lsnr, and some of them are like .dg. So you should understand what are those, like .lsnr for your listener, .dg is for your disk group, dot VIP is for your, .asm network is for your network, and then some of them are like .db is for your database, and .vip is for your VIP, that virtual IP. All of them will see in deep dive, and we'll try to understand each and every concept of that. But yeah, you should thoroughly look into that. Like some of them are, you can see .srv. What is that? That's a service name. So you should understand all those concepts in bit by bit, and then once you understand everything, so that you can easily manage your whatever the cluster with issues, you can easily handle them. Right.
Only one
So
question.
yeah,
All the scan VIPs are assigned by ourselves, or clusterware automatically assign those IPs?
whatever that VIPs, node IPs, scan IPs, everything will be like defined while installation. So
Okay.
that we're gonna see it during the part of installation, how you're gonna assign, how you're gonna build up. So this will be part of your network admin task, but you have to provide him. Okay, I need 3 VIPs. I need four nodes with the 4 physical IPs and 4 virtual IPs for that node. And then I need 4 private IPs for that particular 4 nodes. I need 3 VIPs for my scan. I need, this is going to be my scan name. He's going to define everything inside his DNS router, and then everything will be set at the network level. But you have to define and you have to assign it to clusterware while building your clusters. I will see it as part of our installation.
Okay.
Right. So this
Malik,
is
sometimes this CRSCTL stat command doesn't work. Like it says the command doesn't recognize. So what could be the reason for that?
command does not recognize. So you have to set the environment. If you don't set, you cannot run it. .env grep. You have to set it to your ASM, then only it will work. .env grep Aura, it's a plus ASM. It's a pointing to grid home. If you don't set it to grid home, then it command will not work.
we need to set the path also, pathway variable.
No, you have to set the dot .ini. The moment you set the dot .ini, everything will be set. Otherwise, you have to set export path equal to $path and your grid home bin, all those things you have to do it.
Okay, so
Like the
this
moment
will,
you dot .ini, everything will be set for you, plus ASM1 plus ASM2.
okay, this command will work in IBM AIX also.
IBM AX is a different command, so there you need to export manually. So there are some different utilities.
So like what value we want to we need to set for the path?
That I will get back to you. IBM is a different concept. Like you cannot use this whatever they export and all these things. But yeah, you have to make sure that you have to set your ASM SID base Oracle home and echo $path. The moment you set your path, you can see your grid home is set here. So everything is set it properly, path, even Oracle home base and SID. And then the moment you do whether your commands are working or not, you have to do which CRSCTL. The moment you do which CRSCTL, you should it should point to your grid home bin CRSCTL. If you do which SRVCTL, you can see it is pointing to your grid home and bin CRSCTL. The moment you do which command, it's going to give you that whether the path is perfectly set or not. So if I go exit, and then if I connect back to Oracle now, if I do env grep Ora, and then right now I don't have any Ora environment set here. And now if I do which CRSCTL, it will not give me that location. It says no CRSCTL. So if I try to find the run this command, it's going to say that command not found. See command not found. So the moment I do .env plus ASM1, and then now I do which CRSCTL, it will be point to my grid home, and then it will get it from the grid home bin CRSCTL. Now if I do CRSCTL start resource -t, I'll get the output.
Or otherwise we can go to that path and run the command there.
Yeah,
then
that also works. So if I exit here, and then if I do env, if I do with CRSCTL, right now no CRSCTL set, so I'll just directly go and then do the full path, user on app 19c grid bin CRSCTL, and I'm going to use the same command. You can directly go till that path and run the command without setting the environment.
Yeah. Thank you.
Right. So this is like this is your clusterware startup sequence. So these are your clusterware resources. These are the one which will get started, and then once these are get started, which will form your entire clusterware ready for use. And then there are many services: your ASM service, your cluster interconnects, your CRF, CRSD, CSST, CSST monitor, CTSST, Diskmon, and your ACFS driver, UEMD, GIPCD, GPNPD, MDNSD, and storage. So all of them will gonna form your entire clusterware setup. And then once all these services are up and running, then only you can continue to work your all databases continue to operate and other things. If any of these services go down, your entire database or all the services will go down.
What is that offline one showing here? Is that disk commit or what?
It is Diskmon. Diskmon is used only in your Exadata. So in your normal Linux or normal server, you don't use our Diskmon. Diskmon will be used only in Exadata box.
Okay.
Right. So your
Malik, where this logs file will be reset for each these services?
Yeah, we will talk on that. We'll come to that point in a minute. Yeah. So each of these services will give in this particular order, but the startup will be like depends upon each of these services. Like the moment this service to start, and it may be depends upon this service, and this service to start, it may be depends upon this service. So they have internal dependencies. To avoid that internal dependencies, the clusterware will start in a phase wise. You can see it has typically it has 4 phases: level 1, level 2, level 3, and level 4. These are the 4 level services your entire cluster resource will get started. So the moment you do CRSCTL start CRS, I'll just exit .env. So the moment you do CRSCTL start CRSCTL start CRS, the moment you do CRSCTL start CRS on that node, your cluster will start booting up. And then very first it will start is your OHST, Oracle High Availability Service Daemon. OHST stands for Oracle High Availability Service Daemon. So the moment your Oracle High Availability Service Daemon starts, so that internally starts your the two very main agent. One is your Vora root agent and other one is your Vora agent. Vora root agent and Vora agent. These are the two main agent it gets started. And then along with that, your CSST agent and your CSST monitor. That is your very first level when your OHST is started. These are the 4 services will get started. And then your in the second level, your CSST agent will start your CSST daemon, and your CSST monitor will start your CSST monitor daemon. These two like one-to-one mapping. Your CSST agent and CSST monitor in respectively will start your CSST daemon and CSST monitor daemon. And your Vora root agent and Vora agent internally start a bunch of services. If you go with your Vora root agent, it's going to start your CRSD, CTSSD, Diskmon, and your ACFS driver. These are the 4 services which will be started by your Vora root agent. And then your Vora agent internally starts your Oracle ASM and GIPCD, GPNPD, EVMD, and MDNSD. These are like bunch of services started with your Vora agent. And internally, this your CRSD process, whichever started by your Vora root agent, is going to start again 2 more agents. That is your Vora root agent and Vora agent. So these 2 agents are going to get started in your level 3. And then these 2 agent, Vora root agent and Vora agent, internally starts remaining all the services. This Vora root agent is going to start your GNS, ACFS registry, your scan VIPs, your GNS, your node VIPs, and network. Mostly your the Vora root agent started by your CRST will responsible for taking care of your network related services, and your Vora agent, which is started by your CRSD, will be responsible for starting rest other cluster services. Your like ASM instance, your ONS, EONS, GSD, listeners and scan listeners, and all other services. So these daemons, whatever we are talking about, you can list it out using something called ps-ef grep d.bin. The moment you do d.bin, you will see all those services whatever we talked about here. Your CSSD OHSD.bin is the one which is going to get started first, and then after that it's going to start your Vora agent and Vora root agent. These two are like agents started by your OHSD, and then after that it's going to start all the remaining services whatever you're going to listed out here. So you can whenever you do cluster startup and shutdown, you regularly start doing checking this ps-ef d.bin, and if these services are getting increasing or getting down, it means your cluster is going down and going up. You can make sure that your cluster is going down or your cluster is coming up. Or other way to check is like regularly check your crctl stat resource -t-init. These services are going down and these services are coming up. You can see it. Right. So this is a quick intro about like what we discussed. Level 1, level 2. It's going to start with the same thing. In 11G, we had something called init.ohsd, which will be defined in your etc init tab. And then from there, you are going to respan this init ohsd process. But in 12C onwards and in your 19C onwards, you no need to depend upon your init tab. It's going to be defined as your init process. Will be like your init OHST process will be started as a root processes. So that will take care of your defining your OHST script. So this is kind of a wrapper script which will define your cluster startup sequence. What are the dependencies and all those things. And then these are like respective run level, level 1, level 2, level 3, respective services, whatever will get started. And level 2 again bunch of services, and level 3 again 2 more agents, Vora root agent and Vora agent. And then again level 4, your CRSD root agent and CRSD agent, which is responsible for starting other resources. And then some description about all whatever that resource name is. Right. So that's quick intro about how the clusterware startup sequence works, and then your node, whatever we talked about. In 11G, we had something called ETC Oracle resource, but in 19C, everything will be part of your clusterware demand. Right now, you can see here. If I go here, node name, and then inside, okay, right now I'll go inside Oracle. Okay, you can cat this file. Right, and then nothing is here, and then go inside root. So there's a slight difference between your 11G and then the 12C and 19C that we're gonna talk about more when we start our actual class. Okay, this is like your clusterware daemon is clusterware resource is always auto restarting. Means the moment this node goes down and comes up, automatically your cluster resource will be started. And then sometimes you need to disable this cluster auto start. For example, if you're doing a patching, you don't want your cluster to start again and again, because when you're doing a OS patching, your node will go for multiple reboot. For example, I'm doing this node 1 OS patching, the kernel patching. So during that kernel patching, my server will go for multiple reboots. So during the multiple reboots, I don't want my cluster services to start again and again. So you have to disable your cluster startup, automatic startup of your cluster. You need to disable that. So you can disable that automatic cluster start by defining your OHSD run, restart or stop or disable. Everything you can define it over here. Whatever this cluster restart you're going to do it, whether it is enabled or whether it's a disabled. So what I'll do now, I'll do cat of this CRS start. So right now it is like enabled. Now if I do CRS ETL disable CRS, CRS ETL disable CRS, right? What happened? Disable is a typo.
Yep, typo.
Yeah. Okay, so what I'll do now, CRS ETL CRS. Right now you can see Oracle High Availability Service auto start is disabled. So if you reboot this node, your cluster will not start automatically. But now you can go ahead and check this CRS ETL restart. Now you can see this is default enabled. Earlier, if I check this OHSD run, auto restart and OHSD, these are like, in your 19C and your 11G, lot of changes are happened. So we're going to understand what is this CRS CTL restart, what is this OHSD init PID, and the moment I cat this init PID, whatever this PID it's going to start, all the PID will be registered here. ps-ef grep d.bin your where is that one? 1876. Okay, lsof will give that one. Okay, not giving. So yeah, this particular PID is the one. The moment you start your clusterware, one particular process ID will be assigned to your OHST service, and that particular OHST service, that ID will be kept under this particular file. The moment you shut down, your PID will be gone, and then the moment you do any disable, enable, stop, start, based upon that, your all the files will be get updated regularly. So we'll understand in details what is this OHSD run, OHSD start, and OHSD init PID and CRSD start, and then why it is having it enabled, and why this OHSD run is like disabled, and why OHSD start is disabled. All these things we'll understand in deep more once we start our regular class. But these are the files you should understand. This is a location which will be having your cluster level information, whether cluster is enabled or whether cluster is disabled, and what happens if I reboot my node, or if I reboot my cluster, whether my cluster will be automatically back online or not. By looking at these file, you can see it out, you can define it out. Yeah, so those are the one which are like high level basic configuration files, which will define whether your cluster is starting or not. Right, so this is will be inside your etc Oracle, your SLLC's cluster service and node name and the root and your OHST run or OHST start or other things. So I'm just given a brief introduction, brief description about what are those files, how to read them. So we'll see more in details once we start that. Yeah, but just to think that these are the files which will define your cluster auto restart, cluster enabled or cluster disabled, all other things. Right, and then more on CRSCT start, you can see whether it's a disabled or enabled. You can see it out here. CRSCTL file to be disabled. You can see it, that file CRSCTL start is disabled or enabled. You can get from that particular line. And CRSCTL start enable, and whether it's enabled or not, you can see it, all of them over there. Just running by the command, the file will be get updated. Right, and then other things. One of the common questions, whether my database is the RAC database or not, how you can verify it out. The cluster underscore database, which is set to true, then that indicates that's your RAC databases. If I go back here, ps-ef grep smon, these are like so many databases we're running here. If I do ps-ef grep on the other node, so many databases, so many instances, all will be running here. And then .varinv plus asm, do crctl stat resource -t. The moment you do stat resource -t here, which will give you, you have to look for the .db, ending with the .db, all are your databases, like, .db. This is the name of the database, the DB unique name, that single is the DB unique name, and this is a database name, and which is like offline. And then go back here, RAC1N is a DB name, and then that's a type is DB, and which is online, which is running on node 1. And then RAC12C is again type is DB, which is running under node 1 and node 2. If you see like which is running under node 1 and node 2, it's a RAC database. Which is running under node 1, then either it may be your standalone database or it might be your Oracle RAC1 node. You don't know, like you cannot define it. But to find out whether the RAC database or not, you can see Oraprod, which is running under node 1 and node 2. You can see it's a RAC database. And you can see Vara 19C, which is running only on node 1, it's a standalone database. But sometimes, assuming that this RAC 12C, which is configured as a 2-node RAC, and later you have removed this particular second node and you made it as a standalone database. And then that time this entry will not go out of your cluster setting. You have to manually remove them. And then by looking at crctl stat resource -t, you cannot tell whether RAC 12C, whether it's a RAC DB or not, because one will be online, one will be like offline, and whether it's a removed or whether it's a really off, you don't know. For that, you need to connect to database and check your cluster underscore parameter that will define whether it's a RAC database or not. So now I'll connect to this RAC 12C. I'll just log into Oracle and I'll set the environment to RAC 12C1 and then SQL plus /SSDBA and do show parameter cluster. You can do show parameter cluster or show parameter cluster database, cluster underscore database. If you see this cluster underscore parameter is to true, it means it's a RAC database. That's one way you can verify it. And then otherwise you can do srvctl status database -d, and you should know the database name. Your database name is your RAC 12C. If you know the database name, you can do srvctl status database -d and then your database name. And if it's a RAC database, it will be running under multiple nodes. And if it's a down on the other nodes and running on only one node, again you cannot define whether it's a RAC or standalone. And then other way to verify whether it's a RAC database or not, you can do srvctl config database, srvctl config database, srvctl config database -d, and then the RAC the database name. That config database will give you the type of database. Type of database is RAC database. So that will give you whether it's a RAC database or standalone database. So if I do srvctl config database single, so single is the database name, and then type is again it's a RAC database. And then even this cannot guarantee because this srctl config parameter, I can update anything I want here, but that's not dependent upon my database. I can do any modification here on fly, so that will not impact anything over here. And then whether really it's a RAC database or not, you have to connect to database and you have to make sure that check your cluster underscore database parameter. If it is set to true, it doesn't matter whether you run from 1 node, 2 node, 3 node, 4 node, but this is a RAC database. If it's set to false, then it's not a RAC database. That's the easiest way. You have to connect to your database and check for your cluster underscore database parameter. That's the ideal way to check whether your database is RAC database or not. Right, so you can see this is a RAC database or not.
Sir, we can also check the P file.
P file, it will not tell you whether it's a RAC database. Okay, that cluster database will be set. Your P file might be like somebody might have modified or somebody might have edited, or it might be, it's not guaranteed that P file also will tell you whether it's a RAC database or not. But again, it might be true or false. We don't know. Somebody might have edited, somebody might have wrongly defined. But only ideal way is to connect to database and check your cluster underscore database parameter, and then do srctl
What if
status.
we create a P file from SP file? That won't be like
that will be there. Like your P file,
correct.
SP file, yeah, all those will be having the same information, whatever you're seeing here.
Malik, what is the advantage we'll get if you run the single instance on the RAC?
Single instance on the RAC, no advantage at all. So it is like, your resource contention. For example, I have my 4 node cluster. I will use first 2 node for my production use, and then my RAC database will be running 2 node RAC database and node 1 and 2. And then node 3, I'll use it for development use. I'll just create a single instance on node 3. I can give it to my developers. They can use on node 3. And then I can run some databases on node 4. I can use it for the backup or some other reporting purpose. So it all like depends upon how you define, but there's no advantages.
There is one more database, MGTP. It is there in 19C.
In 12C, it is a mandatory. The moment you install your clusterware, the management database is default is coming. But in 12C, in 19C, it's not a mandatory. You can, there's an option to whether you install or not. But this is my 12C. I just upgraded 12C. The default MGMT database was created, and then from 12C I upgraded to 19C, and then the database is still continued with 19C. But in 19C, you have option whether to create your management database or not.
Can we create a RAC database without ASM?
ASM is a mandatory. You cannot create a RAC database without ASM.
Because one of our customer, we are running the database RAC without ASM. I got surprised how it is running.
No, ASM, he might be.
What is the database version? What is the database version for that?
19C.
Oh.
Okay, he might be using a Flex ASM. Did you check with the Flex ASM? Because with Flex ASM, you no need to run your ASM instance. ASM instance will be running on some other servers, and your database will be running in some other servers.
Oh, okay. How to check that Flex ASM?
CRSCTL. CRSCTL. Wait a second. Flux ASM. Flex ASM. Sorry, it's a Flex ASM. CRSCTL. Whether it's a Flex ASM is enabled, then your ASM instance is not mandatory. You can run only database instance. ASM, this is the one inside your ASM CMD show cluster, whether it's a Flux node is enabled or not. Okay, here show cluster mode, not set it to plus ASM. Okay, it's enabled. Flex mode is enabled, and then once you enable, you can define your ASM into some other servers. This node 1 and node 2, you can use it for your database, and for your ASM you can run it from any other server.
So ASM will run in another server, right?
Right.
Okay.
Yeah, but yeah, you have to check like this other one. Where is that one? There's a CRSCTL query also to check your CRSCTL show cluster. Okay, yeah, let's check that one. Right, so this is one way, like might be flex cluster or might be some other, what we need to understand what kind of cluster is running. Okay, so other RAC features are your scan. We already talked. Scan single client access name. It's just a single name we're giving it to end users or application. Internally, it will run 3 scan listeners. Will be like handle your load balancing and take all the client connections, and then it will pass it to that node list local listeners, and then it will balance the load. And then Clusterware and ASM share the same home. In 10G, you have to install 2 software. Clusterware software is different, and your ASM software is different. And then later you need to install your RAC databases. But in 10G release 2 onwards, they combined your Clusterware software and your ASM software. They combined and they made it as a grid home. So if I do cat etc RAC tab, so this is one, like your user and app or user and app 19C grid. So they came up with a grid infrastructure software. So this is your grid infrastructure software. This grid infrastructure software they combined with your Clusterware software, which is responsible for making all the cluster nodes or make them as a single cluster. And then your grid software is for running your ASM instance. Combining them together, they made it as a grid infrastructure software. That's your grid infrastructure home. That's apart from your database home. And then there's a time sync. They came up with your CTSSD, CRS. CTSSD is again one more feature. CRSCTL stat resource -t-init. So your CTSSD, which is in observer mode. You can see it's online node 1, and it is observer mode. What is this observer mode means? It's a time synchronization service daemon. So if your cluster nodes are synced with your NTP, then your CTSSD will be in observer mode. If you don't have a NTP server, and your CTSSD will be in active mode. Your CTSSD will be active online, and it will be in stable state, and that will be like responsible for making a synchronization between your cluster nodes. So that depends whether you're using CTSSD or not. If you're using NTP, then CTSSD will not be used. And if you're not using NTP, your CTSSD will be used in your cluster. And rebootless restart, again introduced in 11G release 2. Your CSSD is responsible for shutting down that particular node, like you're rebooting the node, evicting the node. You don't need to bring down everything. So that is kind of a rebootless restart. And HIP came with in your 11G release 2. HIP is nothing but your redundant interconnects. So whatever intercommunication between your cluster nodes, if one interface goes down, your entire node will go down. So to avoid that, they came up with the multiple interfaces, so that one interface goes down, other interfaces will serve that one. That is like HIP, redundant interconnect. Right. So and then other important thing, your Clusterware troubleshooting logs. It will be all logs, whatever the service we talked about, CRSD, CSSD, CTSSD, daemon, like GPNPD, all these services, whatever services you're going to see it, all will be inside your grid home log and then the node name. If I go here, this is my grid home, cat/etc or a tab, and this is my grid home. If I go inside my grid home and do ls, inside that, go inside grid home, and then the log and then the node name. Go inside log and then ls and then the node name, node 1. And then if I go here on the other node, grid home, log, ls, and then here will be node 2. If I go inside node 2, and you'll see all the services here. And on the node 1, if I go inside my node 1 name, ls, and you can see all the services here. So all the services, they have their own respective logs here. So the node name, go inside that, and you can see all the logs here, including your alert log, ASM alert log, and then all those things you can see it over here. So for example, if you're not able to go inside that, what you can do, I'll just go one at a time. You can do CRSD, you can do locate CRSD dot TRC. So in 19C, it become a TRC. All the log files, they started with the naming convention .trc. In 11G, I think in 12C node, they started with the TRC. In 11G, it will be like CRSD.log. Now in 12C nodes, it will be like CRSD.trc. It will be like same location, like, it will be inside your grid base location, diag, RDBMS, and node. So if I tail this one, tail -f, and you will see all those CRSD related trace files. And then if I do gipcd locate and then gipcd dot trc, it will be like same location, whatever you're seeing. This is your grid Oracle home or grid home base, diag, CRS, and node name, and then the CRS, and then the respective trace files. So same thing, your diag, sorry, the Oracle base and diag, CRS, and node name, and then your CRS, and then inside that trace, you can see gipcd.trace tail-f. And on the both the node, it's going to be same. So I'll just go inside till user and app Oracle diag, CRS, node name, CRS, and then the trace, and then do ls-ltr here. And you'll see all the logs, all the service related logs, you will see it here. All your whatever the service demands, all the logs, you can get it over here. And then both the nodes, the same location, it will be in your diag location. But in 11G and nodes, 11G and all, it will be like inside your grid home log, and then the node name, and then the respective log. So if still I go inside the same log, cd dot, so this is the same log what I'm talking about, ls, and then each of them will be having its own directory, but you don't see anything over here. So that is your 11G nodes. It was a default log location for Oracle home log, and then the node name. And then in 12C nodes, it all been changed. It will be inside your Oracle base, diag, CRS, and node name, CRS, and trace. And then you'll see all the particular service log file, and then log file will be ending with the .trc. In earlier, it was the .log. Now in 12C and 19C, it become a .trc. So you can check it for any log you want, any service demand log. You can just do crctl stat resource -t and -init, and you can query for anything. You CRSD you want to check, locate, and then CRSD.trc. Or else you can directly go till this location and then do LL, your CTSSD, your CTSSD.trc, and then what? .trc. .trc. Okay, your CTSSD will not be used because it is in observer mode, and you can go with your gipcd .trc, and then your gipcd log, and you can go with your CRSD LL CRSD.trc. This is your CRSD log, and your CSSD log LL CSSD.trc. This is your CSSD log. Okay, locate CSSD.trc. Okay, it will be OCSSD. So sometimes you cannot get it if you check for like CSSD, you should be like OCSSD. So that's one way you can verify by locate command, or directly go inside that and you can query for those trace files. And then you can tail those individual log file while troubleshooting your clusterware startup, why it is not starting and all. And then you can see what's happening and why it is not starting. By looking at the error message, you can take appropriate action. And if there are any errors, warning, these are like info. Right now, everything is running fine, and you'll see info messages. If something wrong with your cluster, you can see warning, or sometimes fails, or sometimes errors. Right, so this is your clusterware troubleshooting log, and then your ASM/CMD logs will be inside your Oracle base, and your let's go here, Oracle base, $Oracle base, and then go inside your CFG tool logs. And then inside that you will see all of them, your ASMCA and your DBCA, Netka, NetMGR, and your SQL patch, all those respective log, you can see it inside your CFG tool logs. CFG tool log is other way you can verify your logs, like anything you're troubleshooting with your ASM related ASMCA or ASMCA command line, or your DBCA, DBUA, your SQL patch or Netka, or your anything related to that, you can check your CFG tool logs. And then your ASM related logs will be your Oracle base, that's your grid home base, diag and ASM plus ASM, and then ASM instance, and then the trace. You can see your ASM log over there. And then you can see why your ASM is not starting, what's happening with your ASM, all those things you can check it under your ASM log. And then your diag collect is one more other thing. Diag collect will collect, it can be run as a root user. It will be inside your grid home and bin. It will automatically collect all the support bundles, which will be very much needed for your Oracle support. Anything you are working with your Oracle support, the first thing they will ask you to collect your diag collect. So with that you have to run it as a root user, which will collect more information. It can be run as a grid user as well, but advisable to run as a root user, which will collect more information, and then you have to pass it to Oracle. So that will collect more logs for your support, Oracle support, and then pass it to your Oracle team. So it will collect everything, CRS, OCR, and ORA data. All them thing will be collected and it will be sent to Oracle support. Great. So some of the other question, how your OHSD is not starting, CRSD is not starting, your CSSD is not starting, your GPNPD is not starting, and then some others, your CSSD is not starting, and how we can troubleshoot, what are the log files you're going to check it out, what's the dependencies. So yeah, all them will see more details in later part. But this is like you have to think of, like, if your ASM is not starting, your CRST is not starting, CSSD is not starting, your UMD or GIPCD is not starting, GPNPD is not starting, what to look, which files to look, and what's the dependencies. Why my OLR is my OHSD is not starting, might be your OLR is corrupted on that node, and then check for your OLR. How to check your OLR is correct or not. There's a OCR config tool. We can -local. You have to use that OCR config tool and check your OLR is correct or OCR is correct or not. So all those things troubleshooting, we can check it out. Yeah, and then there are like bunch of RAC administrative command I just put here. How you can verify, how you can stop your clusterware, how you can check your clusterware, what is run cluffy, and then what is this OCR config. How you can somebody asked, like, take a backup, right? OCR config is a utility. We are using that utility to take my OLR backup, OCR backup. To restore also, we are going to use the OCR config, and then all those things. So somebody said, like, listener, how to register a listener, right? SRUCTL, add listener name, and then to add it to clusterware. All those, like, clusterware administration, you can do it. How you can stop your cluster, how you can start your HS, how you can enable, disable your CRS, how you can stop, start your CRS, how you can check your cluster on all the nodes. It will check cluster all, will give you from all the cluster nodes. Yeah, these are like basic administrative command. We can run it and manage it. And then some of the other things, how you can check your voting disk OLR, and then how you can restore your OLR, OCR, how you can verify your GPNPD, where is your GPNP file, and then how you can move your voting disk from one disk to other disk. Somebody asked how to read my voting disk, right? Like, you have to use this kfed read and then your disk name. There are many grep you have to, like, there will be like random data you cannot understand. You have to grep whatever you needed. So many things. This is also one of the attachment which will talks about all these commands. So you can just use those commands. Right, so a bunch of these like slides attachments here, like all will be talking about the same, whatever the administrative command, whatever we are running it here. Right. So some of the advantages and benefits we already talked: high availability, scalability, manageability, reduce the cost of ownership, and then load balancing, and then your vertical and horizontal scaling, your resource manager, managing your resource. All of them are your advantages of having your Oracle Clusterware or Oracle RAC databases. Right, so that's pretty much what I wanted to cover. If you have any questions about the course or the content, then we'll talk. Otherwise, we are good to wrap up for today. And then
next weekend when we start, we will start from installation of Linux or from where?
Installation of your Linux and configuration of Linux. We'll start with 7.0, and then we'll clone that, and then we'll followed by some of the prerequisites RPM installation. We'll start with virtual machine setup, OEL installation, creating users groups, your DNS name server configuration, and then clone the VM, create a shared disk, configure your Oracle ASM pre-checks. All will start from the scratch.
Can you share the documents? So would like to, install at least OS ready.
Right. And then in fact, if you don't want to go with the installation and try with the installation practice and all those things, if not possible, then you are already one of the VM lab. If you go here, ready VM, one of the lab machine is already uploaded. Oracle lab 1 is uploaded. You just need to clone it as a Oracle lab 2. You can download this one. If you want to create by your own VM, you can create it. Or already ready ASM is already uploaded here. It's a 2-node rack already set up. ASM is installed, database created. You just need to unzip and then you can make use of that.
Okay. Yeah, we'll do that. It will save time, but definitely would like to go through exercise as well.
Right. Yeah. All right then.
Manual steps will be covered next time, Malik. The manual steps of installing will be covered, right, in the upcoming sessions.
Manual steps of installation. What manual steps you are looking for?
For the VMware setup.
Yeah, VMware setup, everything will be covered from the scratch. From the scratch will be covered from next weekend onwards.
Yeah.
Sir, do you have rack ready machines? Because it takes a lot of time to install. We have not.
Here I told you, right? It's a 2-node rack setup with ASM and with database already ready. You just need to unzip and then just use them.
Okay. So we will be working on 2-node rack.
Right, 2-node rack, and we'll be doing one demo exercise, adding one more extra node to that. And then later we'll be removing one node. So that's one of task at the end of this course, adding and removing of the node from the clusterware.
Okay, thank you.
Malik, I have one question. I think you have worked on extensively on EBS and Exadata as well, right?
Right.
Are you planning any of the series for those things?
Exadata definitely no, because the lab infrastructure is a very challenging one. But EBS probably we can plan it out. EBS we can.
Exadata, is there any simulation?
You can set up your own Exadata lab by using Oracle VirtualBox, but you need in terms of terabyte of space in order to form your cell disk and all. You have to.
Is there any simulator is there or how?
No, online simulator you cannot do it. There's no simulator, but you can build your own Exadata setup in your VirtualBox, but that needs 1 terabyte, 2 terabyte, 3 terabyte kind of storage. So it's a huge.
Okay.
Right, so somebody is asking, is there any break? Yeah, obviously it's a long sessions, like every day, Saturday and Sunday, 4 hours. We'll take first 2 hours and we'll take a break for 10-15 minutes, and then we'll continue with the other 2 hours. Yeah.
Hi Malik, this is Chandra.
Yeah.
Any weekdays batches available in RAC?
No, as of now, no weekday batches. All right, so if no more questions, then we can wind up here and then we'll connect on next weekend, guys.
All right, thank you.
Thank you all. Bye-bye.
Hello, Malik.
Yep.
Did you say we're going to continue again?
No, we'll continue on coming Saturday as a regular classes.
Okay. Do we have class tomorrow?
Yeah, the regular database class will be there tomorrow.
Okay. So when is the RAC class is gonna begin?
RAC classes will be at a weekend batch. It will be like coming weekend.
Oh, only weekend, Saturday,
Only
Sunday.
weekend. Yeah, yeah.
Okay. So what about registration? How are we gonna register?
You can make a payment and then send me a screenshot. Same method with your email ID, or you can ping me on my WhatsApp. We'll communicate further on that.
Okay. Okay.
All
Thank
right.
you.
Then. Thank you all. Bye bye.
Thank you.